Oh. Hold on. Under division, ladies and gentlemen. Under division. Under division. And the little, maybe the little subheading for this division, I suppose we can call it long division. That's such a dismal term, long division. It won't be very long for today. They start you off pretty easy. For example, if you have 6 divided into 16. Now, what I need for you to do on this is write down division. We have this algorithm. And if you remember, an algorithm is the order that you do something or the way you do something. And it goes like this. First of all, you divide. Then you subtract. Wait, sorry. Let's change that. First of all, you divide. Then you multiply. Then you subtract. And then you bring down. Now for tomorrow, we won't do a lot of this, but you don't want to have it in your notes because eventually we will. And a lot of times we use those first letters to make some sort of a saying. Well, it's not really that. It's the letter D with the letter M. I can't remember what it is though. Does math seem boring? Never. Does math? I heard a yes out there, by the way. I don't have very good notes. But this is the algorithm that you need to follow. No matter how big or small the problem is, you need to follow this pattern. And once you get to the bottom, you just, kind of cycle it back and you start all over. So the first thing we do, and I've got some helpful hints for you that will make your life so much easier and better. If I'm dividing 6 into 16, it's very important that you stay organized and do things in order. That's why it's nice that there's squares on your paper. 6 does not go into the 1, so there should not be a number above the 1. Okay, you always want to keep it, when you're dividing into something, you want to go into the last digit of the number you're going to do. So the first thing we do is divide, and really dividing, we talked about, is nothing but backwards multiplication. You say to yourself, 16 divided by 6, which really is 6 times what number is as close as we can get to 16 without going over. You have to stay below it. 6 times what gives you close? Chloe?
12.
Yeah, which is 6 times what? 2, right?
Yep.
6 times 2 is 12. So that's your dividing part. You put the 2 up there because you divided 16 by 6 and got 2. Then you go to the multiplying part, which is 2 times 6 is 12. That's your multiplying. Then your subtracting part, which is 4. And you always want to stop there and check. When you subtract, this number here must be smaller than your, remember what we call this guy? Divisor, if you're talking math. It has to be smaller than that, because if it's bigger than that, this number could have been 1 higher. And then you bring down. Well, we can't bring down because we don't have any more numbers to bring down, so that's where you come to a stop. And then, what do we do with this guy here? Because there's no numbers left to bring down. That little guy there we call, River? A remainder. So we write a little r and we put the 4 over there and our problem is done. Now what I'll tell you, fifth graders, is a remainder really makes absolutely positively no sense to you or to me, okay? Because here's the deal. Think about this and see if this makes sense to you. Okay, you have $16. Let's say you had 6 people over to your house for fish and chips or whatever you're doing there. Here's 1, 2, 3, 4, 5, 6. You had $16 and you said, I'm gonna give everybody an equal amount. So you take your $16, divide it by 6, and everybody gets $2, which gives you $12. Well, the remainder means you have $4 back, but if I said everybody gets $2 remainder 4, what is a remainder 4 of $1? Can I give you a remainder 4 of $1? When you go to the store and you buy your compact, what do you buy? When you buy those sneakers, and does the store clerk ever say that'll be $15, remainder 6? No, because that means nothing to nobody. It's just a way for you to realize at the end that you've got some left over, but what do we do with that? Now, you might be able to tell me what actually money you would get, but for right now, we're not gonna get too much into that, we'll get to it later. So for now, it's perfectly okay for you to put remainder 4s, but just know that in the real world, when you go out there and nobody's ever gonna ask you for a remainder 4 of anything. Because nobody really knows what a remainder 4 of anything really is. It just means that after you did this, you had $4 here that were left over, and they didn't go evenly. Not everybody gets 1, so I don't know what you're gonna do with those extra $4. Maybe you'll go buy an ice cream cone and everybody will have a spoon. I don't know. But that's just for right now, remainders are okay. Let's do another one. How about this one? 6 into 50. 6 into 50. Again, 6 doesn't go into 5, and you don't have to put an X there, but just know 6 doesn't go into 5, so there should be nothing above the 5. 6 does go into 50 if I do my little divide, multiply, subtract, bring down algorithm. How many times, Olivia, does 6 go into 50? And here's where you need to know your multiplication tables. Hopefully you don't have to do this, but if you have to, you can on the side go, 6 times 6 is 36. Seems kind of small. 6 times 7 is 42. Oh, that's kind of small too. 6 times 8 is 48. We're getting closer. 6 times 9 is 54. Too big. So I gotta stay with this one here. 6 times what, Lydia? Yeah, so you put your 8 above the 0. That's your division. You multiply. You subtract. If we had another number there, we were doing something else, we could bring it down, but we don't. So we stop right there and we write our answer as a remainder of 2. 8 remainder 2. How about this one? I'll give you one to try. How about 34 divided by 9? $34 divided by 9. Let's see if we all can get that. Again, please stay organized. Do not put whatever number you have should be written above the 4, because 9 doesn't go into 3. Sooner or later it will. Oh boy. Mr. Hans, not a big fan of you having to look at your multiplication tables for this. Because you really, really, really don't want to go to high school and have to have the high school teacher look at you and go, what? You don't know what 7 times 6 is? I don't know. I think Mrs. Luke would be disappointed. Like I said, if you're struggling figuring out 9 times what is close to 34, then I suppose you have no other option than to off to the side here just start doing your 9 multiplication tables. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. Oh, too big, you stop there, go back down here. 9 should be times 3, subtract. And 3 remainder 7. How many people had that? 3 remainder 7? And one more, how about 10 into 42? That one should be pretty simple. 10 into 42. We did the division last year, didn't we?
Yeah, we did. Not as much as multiplication.
Well, you did multiplication, you did division.
He used to go and so.
Use the dog.
I know, right?
Use the dog.
Goes into up on top. I used to multiply S.
Well, if the gums works better for you, by golly, use the gummers.
I didn't get this.
Let's see, what did we end up with there, River? Exactly. 10 doesn't go into 4, but it goes into 42 4 times. 4 times 10 is 40. Subtract, bring down, or subtract, there's nothing to bring down.